Alright team, welcome to this video. What we're going to look at today is this simply supported beams topic again, but how we have to solve a slightly different method of solving the problem if we've got what's called a uniformly distributed load, which we can see up here is that UDL. Right, now what that UDL means is we've got a load represented by those bumps along a section of the beam. Now if we have a little look in this case, we've got a load of 12 kilonewtons per meter. And if we add 1 and 3 up, we'll get that load spread over a distance of 4 meters. So what that actually means is the UDL, uniformly distributed load, is equal to 12 kilonewtons per meter over a distance of 4 meters. So the total force that UDL is putting on there is 48 times 10 to the 3 newtons. 4 times 12. So whatever that value is, we multiply it by the distance it's spread over, and that will give you what that actual UDL load is. Now we've also got this 80 kilonewtons, which is a point load. So we've got 80 times 10 to the 3, and then we've got this one here, which is also a point load, and that is 50 times 10 to the 3. Alright, so the total force acting on this system here is 48 plus 80 plus 50, which will give us a total of, let's put that F in there, will give us a total of 178 times 10 to the 3 newtons. Now from our previous video, we'll remember that whatever force is coming down on top of the beam is classed as a clockwise moment, and then whatever is going up in that direction is classed as an anti-clockwise moment. Okay, so for this beam to remain in equilibrium, the support reactions at R1 and the support reactions at R2 must equal whatever's coming down on top of the beam, which in this case is 178. So let's go through and solve this problem. So the first thing that we need to give some consideration to is trying to remember our moment calculation. Moment equals force times displacement or distance in this case. So if we've got 3 forces acting down on top, let's call these 1, 2 and 3, it means that for our clockwise moments we're going to actually have 3 moment calculations. Alright, and I'll put clockwise equals anti-clockwise here, and we'll fire some numbers in and see how it starts to take shape. So the first force that we're going to put in here is this 80 kilonewtons. Now I'm going to leave the 10 to the 3 off for now. Right, so that's our force. The first one is 80. Now how far away is that from the pivot, which as we remember from our previous video is the extreme left hand side of the beam here. So that distance is actually 1 meter. Next thing I'm going to do, I'm going to add my next force, which for this one I'm going to use this 48 kilonewton force, 48 times kilonewton, and I'm going to multiply that by a distance. Now the distance I've not decided yet, but again, you remember from our previous classroom sessions, we're going to take our UDL and we're going to turn it into a point load. Now it would make sense that that point load would act at the centre of the distance that the UDL is spread over. So for this case, we know from our previous calculation here, that's 4 meters. So the centre of that force, or the centre of that load, is going to be at a distance of 2 meters. Because from the pivot to the centre of the load is 2. Okay, next thing, we're going to add the final force, which we've got as 50. And we're going to multiply that by the distance. Now the distance we've got here again is 3 plus 1. The case 4. And that's going to equal the anti-clockwise moments. So we don't tend to use F when we're doing this. We'll talk about support reactions. That's where this R here and this R comes from. So we'll actually say R2 times the distance. Now the distance, as always, is from the pivot. So the support reaction, R2, has got a distance of 5 meters. Alright, so we want R2 on its own. So we're going to divide both sides by 5. Divide by 5. And these will cancel out here. So when we've popped that into our calculator, the support reaction at R2 is going to equal, and I'll give you a minute to calculate that. So the support reaction at R2 is 75.2. Now I left my 10 to the 3 off here, but I'm going to need to put that back in when I've got my final answers. So that's the support reaction at R2. So this clockwise moment allows us to calculate this support reaction. Now whatever's left from our total force is going to be R1, because we've only got 2 points. We've got R1 and R2. So whatever's left. So to calculate R1, I'll pop that down there. R1 equals the total force acting on the system minus the support reaction at R2. So we can remember from our previous work there, we've got 178 times 10 to the 3 minus the support reaction at R2, which gives us 75.2. So the support reaction R1 is equal to, I'll give you a sec to calculate that. That's right, 102.8 times 10 to the 3 newtons. Okay, so I'm just going to grab that different colour pen, and I'm going to double underline these so we can highlight the answers there and there. Alright, so very similar to what we've done previously, except the only difference, we've put a uniformly distributed load in there, is we've got a little bit of thinking about in relation to what the total value of that load is. So for example, we in this example we did 12 times 4, which gave us 48 on this one. And then the next thing we need to consider is this distance, which we had here is 2, because the distance in total is 4, and it would make sense that the centre of that would be bang in the middle, which is obviously 2. Okay, now I'm going to pop onto the next slide. On there you'll see another example, very similar to what we've done already, slightly different dimensions, slightly different format, and the UDL has gone all the way across the screen, all the way across the beam, sorry. But we've got our point loads and our UDLs there. Now what I'd like you to do is have a go at that one, and you can then send me an image of your completed work through Canvas, and then I can check that for you to make sure we're on the right track. And actual fact, there's another one here, question number 2, and then there's actually another one, question number 3. So there's a few for you to have a crack at. Alright, if you want to do the first one, send me it, I can check it, and then you can move on and do the rest. And you can obviously just pause the video at that point, and then you can come up with a solution, and then you can play the video, and then that gives you the next questions there. So hope this finds you in good health, and look forward to catching up with you next session. All the best.